first. So I will quote the CEO of my company and say that I think we're kind of getting to the point where you're going to see some consolidation in the market, right? So Hortonworks finally, they went public, was it late last year? I think we're going to see Cloudera and MapR do kind of the same thing here in the next 12 to 18 months. And I think you're going to see a cascade of big data tools that are going to start consolidating into kind of some more predefined areas. And I feel like you've got analytics types of solutions like Zoom and Platforma. You've got some more data sciencey, developers specific types of technologies that are out there. That there's going to be some consolidation around that market as well. And I think that's going to be the big thing. That has a lot of cascading effects as far as what happens with Spark and what happens with everything, right? So right now you've got Databricks, which is its own individual company, not Databricks, it was Databricks. Its own, and then you have DataStax, that's Cassandra, and then you've got like Squirrel, that's a Cumulo, and there's versions, different places that are just supporting, they're like the open source owner of an individual portion of this big data stack. And I think we're going to start seeing consolidation around those types of companies as well.
This might be a fairly narrow view, but I think the thing I would love to see, for those who develop in Python, and you use the Python shell, and then you learn about IPython and the IPython notebook, and it's just such a huge step up in terms of the ease of use and having this kind of graphical layer. You're still programming. You're not pointing and clicking necessarily. You're not like other tools, dropping my papers everywhere. It's just so much more convenient, and you can do that with PySpark. But when I got started with Spark, PySpark was still really raw. I started using it, and then there were all these features in MLlib that were just not there. It didn't support the data formats I wanted. And so I kind of gave up on it and went back to Scala. And after a time, I have plenty of jobs that kind of run in batch, but I think that interactive running from a shell is huge, which is why the Spark shell is so valuable. But having something like that in the browser, I think would be fantastic, and plugging into other tools that have just so much more of a graphical kind of build out to them. And so I know there's an iScala notebook, and there's kind of an iSpark equivalent, which kind of wraps the Spark shell, but they're all very raw, and I think there's a couple companies that are kind of trying to spin that up as their core capability, is kind of this, you're still in the software development side, but you're interacting with Spark in more of a graphical way. So if you're building a machine learning model and you want to dump plots out in Python, it'd be really easy with your NumPy, SciPy, Matplotlib stack. Something that gets to that level of ease of use in Spark, I think, probably won't be terribly difficult, but it'd be really cool when it gets there. And then there's just random asides. My colleagues here who does a lot of stuff with Neo4j and graph databases, and it's cool. I think they're both kind of converging on each other. That I think the ball's already rolling in that camp, but core Spark capability like GraphX and things like that, and then getting more of the visual components with other graph databases out there, and then things that are just really awesome on the visualization side. And Neo4j is just one example of a few. That would be really cool as that matures.
Yeah, this is a broad question. So a couple of big trends we see. We're going to, from a Tableau perspective, we've seen this democratization of BI that's occurred over the last 2-3 years. So looking forward, I think you're going to continue to see with predictive and statistical and even the data science work, that being more consumable by more people. And it doesn't mean that they're going to, yes, there are going to be more data scientists, but the average analyst can leverage churn calculations and predictive calculations in their everyday analytics. So kind of a move to make that easier to consume. As it relates to Hadoop and Spark and kind of the new stack big data play, I think there's a couple of big things. I think Hadoop's going to continue to get more and more performant. All the major players are trying to do it. Spark actually changes the game big time for this. So the rise of OLAP on Hadoop, as an example, is a really cool use case that's making the performance issues that were with Hadoop less of an issue for people, right? So the batch idea can change. Now you can have this more live interaction, which is big. And I think you're going to continue to see players come and some consolidation in the space as well. data wrangling is an example of something that's going to be interesting. So the Excel-like functions that people do, how do you make that bigger, whether it's the trifactors or the paxatas or Informatica's Rev product. These are all people that are trying to get to that analyst. So these ETL players that used to be all IT are like, how do we get the data prep work on the desktop of the analyst so we can actually scale that out? And that's the last point I'd leave you with, is really around this data lineage and governance. As unsexy as governance is, if you trust your data, you make better decisions. If you spend your time questioning the validity of it, then, if you're an analyst, that may not be your job. You're not an ETL person. So as we continue to go here, a tighter lineage between the origin of data and what you do with it analytically, and the more that becomes out of the box, the better the analytics get.
I agree with all of the comments. I think there's some great points made. We're in a data-driven world, right? Me as a person, right, I rely on data whether I know it or not, right? Coming here, just put it into my phone. Waze finds the best way for me, tells me if there's cops on the way. I come in, right, the weather. So I think, like, as we kind of look at the trends, right, it's a data-driven world. People want access to data. The old way of doing it, building the enterprise data warehouse, spending a year kind of consolidating the data into one place and then having a tool that sits on top of it is not the way to go. I think the data democratization kind of brought the desktop tools, let the analysts kind of access the data. Then this thing came called Hadoop, right? And more and more data is being made through Internet of Things and other things that are coming. So the scale out, the performance, and accessibility are going to be really important. And I think that as we look at 2015 and beyond, we're going to start kind of moving away from like vendors pitching about the benefits and hearing hopefully more and more use cases from customers on how they're realizing benefits from big data.
Okay, thanks a lot. So since we reached the future, I want to open it up now for questions from the audience. If you have any questions for distinguished panelists, I think you will first.
Yeah, I have two questions. So one non-related to Spark, one general question. First question: when would IoT and BA marry? Like Internet of Things, right? And BA, right? What's your take on it? I mean, are you envisioning that these would marry in the future, or is it something which is totally human interaction with BA? That's first question. Second question is something specific to Spark. All the tools, right? The Lambda architecture, right? Like this batch and streaming. At least I didn't at least see in Zoom Data is a relatively new company, so I'm not worried about it. But Platform and Tableau, right? I haven't seen that that sort of streaming thing, which I feel that data is time driven. I want your take on that, like streaming and batch Lambda architecture. When would we see that in the BM?
I guess so. I can try to take a chance at that, and then you guys can probably make it a lot better. But I think the Internet of Things and big data and all of that. To that first question, they're close to married now. I mean, it's your data-driven results need all of that, and so I think they're past the dating phase. You're right; they maybe moved in together, and they're seeing how it works. I mean, the scale is what changes the game here a bit. So, an example of that might be if you sample data, you might sample the wrong data. So doing better predictive and better analytics, you actually need the details. So that Internet of Things detail is really important. So, we kind of blend them together in big data, and we think it's, we don't call it one and the same, but it's close. And then from the live streaming component thing, we have some things we do with OData connectors and other things today to kind of get that live feel. For example, if you, sorry about that. I feel like it's close to my
I think the
mouth.
mic's turned off.
I think we lost the mic. Hello? Can you guys hear me?
Is there a button? You can turn it off with your back.
Yeah, let me try to flip it. Oh yeah, our battery is low. Yeah, we got a little.
Nice.
Hey, it's visual. It's an icon. If You guys can't see it.
Shout for a moment.
But,
Try to fix it.
But you know, if you look at the live streaming piece, we feel like there's some moves there, but to your point, it could be better. We've got a no data connector. You can connect to NoSQL databases and kind of get that real time feel of data flowing in. We've got examples doing that, but to your point, it needs to be better. And if you imagine doing that at scale, it might choke quickly. So you know, the example that Ben gave is a really cool one, right? We see customers doing the kind of capturing of the streaming, and then you attach to it. But right now, it's not a simple answer from our perspective. It's not an easy visual thing. I don't know.
I'll say one thing about the Internet of Things. So, I mean, one of the mandates of our lab is kind of rethinking the, certain elements of the banking industry. Because you look at consumer banking and how people do credit cards, and it's been pretty static for a really long time. You have new ways to, mobile payments is something new that's been going. That's not necessarily a new thing. But the notion of having a credit card and you swipe it has been around for a really long time. And for certain problems, like trying to assess whether a transaction is fraudulent, if you can, under this umbrella of Internet of Things, if you can introduce other pieces of hardware or new ways of actually making payments, and these newer things like Apple Pay and paying directly from your phone over NFC instead of just, having your phone always be something that's 12 hours later where you just monitor your statement or something. Having it as an active part of the process gives you this new source of data if you control the hardware end of it as well, where now you have this new stream of data, and whether it's geographic data or an additional form of authentication or whatever it happens to be, it becomes a data problem. So, I mean, I think that's the really cool side of it. I'm not involved in kind of the actual hardware Internet of Things side. I'm be more the data. But yeah, I mean, it just opens, I think, a whole new world of opportunities for that type of analysis.
So from a Platform perspective, I'd say they're more than moved in together. I think they're married, have 2 kids, and moved to the suburbs. So Platform, we have several companies that are already using Platform today to do Internet of Things, including OPower, that's got one of their 2 primary locations out here in Arlington. The reality is, if you're going to stream all that data off of your learning thermostat or your phone or your new internet-connected light bulb, you've got to have a tool to understand all that data so that you can figure out what to do next. And because the scale of the data that you're getting off of all these sensors it is so large, it's already petascale, and it's probably going to be even larger than that here very, very shortly, you have to use Hadoop. There really isn't another solution on the market that can handle the size and the scale of the data with the flexible schema that you would need to be able to handle an IoT type of a use case. So we think it's super, super important. If you go to our website, it's one of the 3 things that is plastered all over it. The reality is,
All fresh batteries.
the reality is, now you can hear me. So the reality is that traditional database-driven tools aren't particularly well suited for IoT type of use cases, just because of the structure of the data that's coming in. You really need this new age of big data and analytic tools to solve for those types of problems. As far as the Lambda architecture question, Platforma traditionally has been more of a one look-back type of a solution. So we have a company that we do work with called Riot Games. They run League of Legends. If anybody's played that, it's like the largest online role-playing game in the world or something like that. And they use Platforma, and they use a Hadoop infrastructure with micro batches to do some analysis in their game. And they're hoping that as a part of this Spark implementation that we're doing, and as Spark streaming becomes more and more robust and whatnot, that we're going to be able to move towards using Spark to create that architecture that you're mentioning, where we're going to be able to kind of fuse the long look-back data with the streaming, near real-time wire speed types of sources. I think that outside of the custom-built solutions, that's still a little bit out in the, if you really want something that's going to solve for your specific problem, you're going to kind of have to build something specific. But I think that gap's going to close here in 2015 if it hasn't, already really. It's just one of those things where you've got to have the right infrastructure behind you. It's receiving that data to be able to answer queries that kind of can incorporate both of those types of sources.
I think, yeah, Internet of Things will happen. The technology, I guess we talk about big data and kind of directionally, my view was we're going to see more and more use cases of this magical thing called big data and how companies are actually reaping benefits from it. So the technology is there to store the data, the technology is there to kind of structure it, and there's tools that can scalably kind of make sense out of it. And then the way I kind of measure things, I use the Waze example. So I guess on Internet of Things, you have the Nest, right? So the smart thermostat. And I guess Internet of Things, the way I describe it is just devices being connected and having a chip in it. And I went to my gym, Sport and Health in Reston, a couple of weeks ago, and their treadmills are connected now. So it has internet, right? So if you go on it, you could actually surf the internet. I'm sure if it's connected, it also means it's probably collecting information. Right, and there's so many use cases I can think of once you start collecting information from those devices, right? And then wearables are huge, right? So we've seen what the phone can do, right? I mean, this device, it's amazing. On Snapchat, I take a picture and then I look at the speedometer, right, in a car, and it tells me from that one picture what the speed is. That's pretty crazy. And then the iWatch is coming out, and the Fitbit and all these other devices. So definitely, it's a reality. We're seeing it in the consumer space. We're starting to hear more and more on the enterprise side, and I think it's just going to validate those use cases around these big data technologies.
Thank you.
I had a question for Ben and Paul. It's one question each. For Paul, would you ever, to play devil's advocate for yourself, would you ever spin it and say, I'd rather you got D3 and got all these different software stacks instead of Tableau? And how would you spin that to a customer or something? And then for Ben, you mentioned that if you see some of these easy solutions that people have on Spark. Could you go into a little bit more in depth into what a difficult solution and like what programming language you use, what you actually have to calculate? Like maybe this is my naivety, but like I'm still missing this connection on where this like I'm still wondering what programming language I would use. You mentioned a little bit. Oh, I'd rather have to use Scala because Python's not ready yet or whatever. Could you go a little bit more in depth on that?
Sure. So the devil's advocate for me is no, I wouldn't spin that you go back to the stack, so to speak. But as I deployed at scale as a customer, and middleware is important. Tools and technology are important for the technical user. And just like we target the subject expert and say this is who we want to empower, as a developer like Ben or anyone else doing it, and what I did in my former life, right, was way more technical. Those tools are needed to add, control, version control, scale, all these other things that, regardless of any tool you use, you still have to have good process and good discipline and good things. The thing that geeked me out about Ben's presentation is he had his notes in his code. If you guys were watching it, he didn't just slap code up there. He actually told you what he was doing in the steps with his comments. That's good code practice, right? So we see an importance for it. The investment Tableau's making there is in our API strategy, in our more technical strategy. We're still trying to make it easy though, even if you're a coder. We want to make it so you spend less time actually developing code from scratch and more time using building blocks that are out there, and that's where open source is cool. But the old stack, I think, has been rejected pretty heavily just because it's slow, costly, and doesn't iterate the way business does. And that doesn't mean you can't deploy it well. It's just hard to come by that. So, we wouldn't really flip it the other way. We believe ease, and our developers want to make the menus disappear. They don't want you to actually notice that you're in the software. They just want you to have a conversation with your data. That's kind of that's a very iPhone way to think about it, right? The iPhone changed everyone's perspective on this whole thing. Smartphones in general, but it came out and it wasn't a better phone than the BlackBerry. It didn't have more feature than the BlackBerry, but what it did better, and people enjoyed it. Right? You liked doing it, and our vision is you have to love what you're doing to be successful, and so we want to create software that inspires that.
So I'll give two examples. The first is what I've been working on a little bit more. So, especially when you're working on a larger team and you're building Hadoop pipelines, you're not running specific jobs. So this is kind of with regard to everything's just text. So our language of choice, or our data serialization format of choice is Avro, but there's a bunch of others out there. There's protocol buffers and thrift and things like that. You're generally not going to structure your data for bigger projects just in delimited text. I mean, it's very risky and it's bloated, it's slow, and there's all sorts of advantages for having something like that. So you start with Spark, and it's one line to read in a text file, and it's great. You split it up and you do stuff, and then you look at some of the examples to read in, say Avro. You know, it's a little bit bigger, and you start getting into the notion of Hadoop writables, and there's some more reading to do and figuring that out, and then you run into, oh, well, Avro doesn't implement Java serializable, so it breaks. So you have to switch to Cryo. And then you start writing some more code, and then it works for some things, and then Cryo is not quite right because of how Java compiles the bytecode versus Scala classes, and then you need to use Twitter's chill layer on top of it for some other types of serialization, and it just gets a little bit more complex just for something like data serialization, which doesn't seem like it should be a big issue, but it kind of becomes a bigger issue. And then I was out at Berkeley's AMP camp a couple months ago, and the Berkeley guys who were doing all the genomics work, the Atom project, they use Avro. So I asked Matt Massey, who's one of the big geniuses there. I was like, well, how do you figure this out? And he's like, well, then we do Avro, and we did all this crap that you have to do, but then we also embedded it into Parquet, and that helps. And it just becomes this much more complicated thing to actually do it. I mean, the data serialization is not really easy. And the second example, I guess, would be, there's examples obviously more complex than just word count or something like that, the hello world. But generally, you don't get a lot of insight into tuning the jobs. And so, you might do a bunch of maps and reduces and sorts and group bys and all these various things. And on paper, it looks like it should work. You're following the API correctly, and then something crashes for whatever reason. And it's really, really cool to go read different, engineering blogs. I read Spotify's engineering blog a lot because they talk about this kind of stuff. And this is not just isolated to Spark. I mean, this is a big thing on Hadoop as well, where for the specific types of jobs you're running, there's often, Hadoop's fairly old at this point. There's still a lot of customization that has to be done for certain types of things. Your join strategies versus your partition size for your data. If what if I have this call logs as small files and I have 10 billion 1 kilobyte files? Like, it doesn't really play well with Hadoop and its 128 meg block size, things like that. So you can kind of read like the theoretical way it's supposed to work according to the API, and there's still like, even for Hadoop, and I think even more so for Spark, they're just kind of like tips and tricks of the trade that unless you're like really deep down in the internals, which I'm not always and not everyone is, there's just, I feel like a lot of gotchas and just common wisdom that has to be gained to get everything to kind of run perfectly. And as you scale, I think it becomes more and more tricky. You just get weird errors that happen. So, thank you.
Thank you very much.
My name is Shamal. I had a quick question on I guess you kind of touched a little bit about this of different levels of caching. So some products like say SAP has kind of, over the last year or two has come up with in-memory databases like SAP HANA. Traditional databases like Oracle also has in-memory computing. So when now you have kind of two layers of caching, if you will. One is with kind of in-memory computing with Spark, and then there are data stores which are in memory as well, like Oracle or SAP HANA. And then you have your BI platform on top of that, say Business Objects or Oracle BI. So how do you guys see that converging down the line? I mean, would you say it's going straight against your Spark or Hadoop versus going against your traditional RDBMS? Both of them being in memory, where do you see the convergence happening down the line?
I think it depends, which is always the best and worst answer to that type of question, right? So for the stack you described, which is a very traditional stack, I think you're expressing the same problem that most of the companies that are here right now are trying to address, right? The whole idea is I want to use less and still be able to get the answers to my questions. And the reason I want to use less is because the more pieces that are of the puzzle that are involved, the longer it takes for me to get the answer to my question, right? So, from a platform perspective, we would love to see a kind of a cache convergence, right? Where we can kind of educate the Spark cache in a way that's going to allow us to do the same types of in-memory calculations and whatnot as we're doing in our in-memory engine today. That would be awesome, because it would allow us to do a lot of really novel architectural things. But I would also caution you around thinking that there's going to be one cache to rule them all, right? There isn't. If there was, they would have solved that problem 20 years ago, right? Sometimes it's okay to have more than one level of cache, because the way that you're caching the data is so different between the different stages that it starts to make sense. It actually accelerates your time to value rather than decelerates it. That being said, I think a lot of it really depends on the roadmap that Spark ends up executing on in the next 12 to 24 months. I know there's more than one way they could go about implementing changes to their cache as they go along, and if they're thinking about how can I get as much of the cache workload off of the downstream tools that are going to be leveraging that technology, then I think you're going to see a very different type of an infrastructure than what they built today, which is really effectively, in my mind, it's kind of a shared scratch base for a Spark context, which allows them to read the data off of disk once and iterate over it many times, as opposed to the MapReduce model, which is every time I need to access a piece of data, I need to go and grab it off the disk again. There are huge efficiencies just in going to that type of a model. So that's not a criticism of Spark or the direction that Spark's gone, but if they're looking at, hey, we want to be the unified cache for all Hadoop big data-based processing, then they're going to have to make some architectural changes there, because right now that cache isn't like wholly, it's not like your Spark cache is consistent across contexts, right? So, if I'm user A and you're user B and we're spinning up separate, Spark jobs, at least maybe this has changed real recently, but my understanding is you're not sharing cache space between those two contexts, right? So, if you're not